Hey guys, welcome back. We'll continue with the book Automate the Boring Stuff with Python. And today we're going to learn how to work with Excel spreadsheets and Python. You can read the book for free by heading over to automatetheboringstuff.com, or if you prefer a physical copy of the book, you'll find a link in the description down below. In this video and the next video, we are going to cover how to work with two popular spreadsheet applications. In this video, we are going to cover how to work with Excel spreadsheets. And in the next video, we're going to take a look at working with Google Sheets. Since Excel is proprietary, you can also use the free applications LibreOffice and OpenOffice. That works just as well. When we work with Excel spreadsheets, we are going to use the OpenPixel module that Python provides, and that allows us to, for instance, read and later on also update and write Excel spreadsheets. So let's open up the new code editor, and the first thing we need to do is to install the OpenPixel module. To do that, we can either click on the gear icon on the bottom right side and then open the tab Third-Party Packages and add OpenPixel and confirm to actually install that module and dependencies. Or alternatively, you can open the command prompt and enter the command pip install --user and then OpenPixel in the version 2.6.2. Once installed, we can open the REPL in our new code editor and type in import OpenPixel. If we don't get an error message, that means we properly installed that module and we are going to use it going forward. Now we are going to be working with an example Excel spreadsheet, and to download that you can head over to the website linked in the book, which is also added in the description down below, and here you have the option to download all the files used in the book. Once we downloaded those files, we can then move the Excel spreadsheet into the folder where we've been working from using the new code editor, and then we can start working with that Excel spreadsheet. Once downloaded, we can have a look at the Excel spreadsheet. Here we can see we have 3 different sheets that are being used, and in sheet 1 we have some data in columns A, B and C, and we can use Python to read the data in this Excel spreadsheet. To do that, we need to start out by actually opening or loading our workbook, meaning our Excel spreadsheet. We're going to call the load workbook function, and we're going to pass the name of the Excel spreadsheets to it. And for this to work, it's important to actually move that Excel spreadsheet over to the folder that we're using with the new code editor, and then we can open it properly. Now we're going to assign that to a variable called WB for workbook. And let's first have a look at the type of value inside of WB. So here we can see it's indeed an OpenPixel workbook, so we properly loaded the Excel spreadsheet. Now with this in place, we can call a number of different attributes and functions on our workbook to have a closer look at the data that's contained in it. Let's start out by calling sheet names, which is an attribute, on our Excel workbook that we loaded. And we can see we have sheet 1, sheet 2, sheet 3, which corresponds exactly to the 3 different sheets inside of our Excel spreadsheet. We can also get a single sheet from the workbook. For example, we could reference sheet 3 and assign that to the variable sheet. And if we then have a look at it, we can see that we indeed have worksheet number 3 that we selected here. And let's also have a look at its type. And here we selected a single worksheet. And we can, for example, also reference the title attribute to have a look at the title name. So in this case, of course, sheet 3. And of course, we can do the same to reference other sheets. For example, we could have a look at the active sheet by calling active on WB and assigning that to another sheet. And if we now reference another sheet, we can see that is sheet number 1, which is precisely the active sheet in here. We can also reference individual cells in our Excel spreadsheet. For that, again, we would reference a particular sheet. So let's have a look at sheet 1, for instance. And then we can get a particular cell, for example, A1. And if we look at our Excel spreadsheet, we can see A1 is this particular column that displays the date and time. So here we can see we referenced that particular cell. And then we can call the value attribute, and that's going to give us the value that we see over here. So we see that particular date and also the time that is added in there. And in a similar way, we can of course also reference other cells, for example B1, and B1 contains the value apples. So if we go ahead and we call value on C, we get precisely that value back. And we could even go ahead and use a for loop, for instance, to loop through the Excel worksheet and, for instance, print out every other cell. So here we have a for loop with the range 1 to 8 and we go in steps of 2. And then we are printing the number of the row, which is I, and then the value of the sheet cell, so in row I and in column 2. So that means we take a look at, for instance, apples first, then pears, apples and strawberries. And these are exactly the values that are returned to us. We can also return the size of our Excel spreadsheet by using max row, which gives us back the highest row number, so in this case 7. And we can also get back the maximum column, which in this case is 3. So that corresponds to the third column, which is of course exactly the size of this particular sheet. Now we can see though that in this case here we got the number 3 back rather than the letter C. And of course in Excel we are generally using letters to denote the different columns. So in order to see the column letter, we need to import a couple of additional functions. So here we are importing the getColumnLetter and the column index from string functions from the OpenPixel utils module. And then we can go ahead and we can have a look at which letter is associated with our column number 3. So we call getColumnLetter and we pass 3 to it. And that's gonna give us back the letter C, which of course is precisely the column we've been looking at. We can also slice worksheet objects to get all the cell objects in a row, column or an area inside of our spreadsheet. And to do that we would create a new tuple here and then we would specify the slice that we want to get in our sheet. So in this case here we are having a look at the columns A1 to C3, which is basically this area here we are looking at. And these are exactly the cells we are getting back. And if we use a for loop, we can actually have a look at the individual values in that area. So here we are looping over all the different cells inside of that area A1 to C3. And then we are looping over all the individual cells in there. And we're printing out the coordinate and also the value. So if we have a look at that, we can see that we get back the list of the individual rows. So here, for example, A1, B1 and C1, which is precisely the first row. Then we have a look at the second row and finally at the third row. So to briefly recap, when we want to work with Excel spreadsheets, we first of all need to import the OpenPixel module. Then we need to call the load workbook function in order to load that Excel spreadsheet. We need to get a workbook object. Then we would use the active or sheet name attributes. We would get a particular worksheet object. And then we can have a look at the individual cells by using the cell function with the row and the column arguments. And of course we can get the individual cell then and then use the value attribute in order to read the cell's value. Let's work on a project and let's have a look at how we can use what we learned so far to work on reading data from a spreadsheet. So here we have some census data from the United States and we have 4 different columns: the census tract, the state, the county and the population. And let's say we want to calculate the total population of each of those separate counties. Even though we could of course select the different cells inside of Excel and get the sum this way, that would still take us a long time. So therefore we can actually use Python to calculate the total population of each county. And as you can see, that's quite an extensive list of values here. So therefore we are going to save a lot of time. So we're going to write a Python script. And it's going to take the following steps. It's first going to read the data from the Excel spreadsheet we just saw. It then counts the number of census tracts in each county and it counts the total population of each county. And then it's going to print out the results. So to start working with it, we need to read the spreadsheet data. And for that we are going to import our OpenPixel module from before, and we are also going to import pprint to more nicely print out the data at the end. Then we are going to load our workbook census pop data. So that's exactly this spreadsheet over here. And by the way, you can download that spreadsheet from the website as well. Link in the description down below. And then we are going to reference the sheets that we are working from. So that's population by census tract. That's the only sheet in here. Now we're going to store our county data inside of a dictionary. So we are instantiating an empty dictionary. And then we are basically looping through each of the rows in our sheet. We're starting at row 2 because the first row, as we can see, just contains the headings. And so we are looping until the very end, and we're getting the value for the state, the county, and the population. Since we want to aggregate that by county at the end, we need to make sure that the key for the state inside of our dictionary that we are creating actually exists. So we are calling setDefault, and we pass the state and an empty dictionary to it to infer whether that state already exists or not. And then we also make sure that the key for this county exists, again by using the setDefault method. And as we are looping through the different rows, we are then also going to increment the census tract by ones when we have that. And of course, we are also going to increase the population here for each of the separate counties. At the end of that, we are going to write the data we have to a new file. We're going to call that census2010.py, and then we're going to close that file. So this is basically throwaway code, meaning we're going to run it once. It's going to extract the data from the Excel spreadsheet and it's going to write it to a new Python file. And then we can work on that Python file. That Python file, of course, contains a dictionary, and then we can call certain commands on it to get the data from it. So let's run our program. And we see we are first opening the workbook, then we're reading the rows, and then we're writing the results, and at the end we are done. And of course that's being printed out because we inserted print statements here, just commenting on what's happening at the moment. Now all this program here did was create a new Python file, census2010, which we opened over here. And here we can see we have a dictionary, all data, which contains a very long dictionary with the different counties, the population, and also the tracts in here. And now we can go ahead, we can open the REPL, and we're going to import the OS module and also the new Python file we just created, so census2010. And we can have a look at the data inside of our Python file. So here we are calling all data, which is our dictionary here. And we are looking at the state, so AK for Alaska, which we see over here. And then inside of that dictionary, we have another dictionary with the different counties. So we look at this county here. And here we get back the total population, so summed up over all the different areas. And also we see the number of tracts. And of course we can extract, for example, the population data out of that. So if we just chain to our call up here, pop, then we're going to get the value for this dictionary value pop. We're going to store that in a new variable, Anchorage population. And then we can issue a print call. Here we're printing out the 2010 population was, and then we add the population. So here, that's a handy way to communicate the data. And calculating all that data by hand would have taken hours to accomplish. So we saved a lot of time. We extracted the data from the Excel spreadsheet, and then we can work on it and issue some queries as we've been doing here to really analyze the data. We can also create and edit spreadsheet files using OpenPixel. To do that, we would first import the module and then call workbook on our module to create a blank Excel workbook. We can then have a look at the sheet names, and we can see we have only a single sheet included. We can then reference the active sheet by calling WB active on the sheet. And then we can go ahead and we can update the title name of the sheet. So in this case, we are changing it to a new name. And if we have another look at the sheet names, we can now see we updated the name. To save our workbook, we would simply call save and pass the name under which we want to save the Excel file. We can also add an additional sheet by calling create sheet on our workbook. And then we can go ahead and have a look at the different sheets, and now we can see we have the second sheet added. We can also delete a sheet by using the del method and passing the sheet name to it. Now if we have a look at the sheet names again, we can see now we only have a single sheet remaining. And of course we can also write values to cells inside of our sheet. So for this we are going to reference a particular cell we want to edit, and then we pass the value to it. If we now go ahead and we reference the value attribute, we can see the text which we provided for the cell. Let's apply what we learned about updating an Excel spreadsheet, and we're going to have a look at a project where we have a list of different produce items. We have a certain cost per pound, the number of pounds sold, and then the total amount, which is basically the cost per pound multiplied by the pounds sold. Now for the different produce items here, we want to update some of their prices. So for example, we have garlic here with a price of $1.19. So we only want to update prices for specific produce. And for that we can use a Python script. Again, we are going to import our module, and then we need to load the workbook. So in this case here, produce sales. We are then referencing the current tab, so this sheet over here. And then we have a dictionary with updated prices. So garlic here, the price should be increased to $3.07. Celery and lemon should also be updated. Now in order to do that, we are going to loop through the rows of the Excel spreadsheet. Again, we are starting from row 2 all the way up to the last row, since the first row here contains the different titles. And then we are retrieving the produce name by having a look at column 1 and getting the value, so the name of that particular entry in that cell. And if that produce name is an element in our dictionary up here, then we're going to update column 2, which of course is a cost per pound. Meaning if we find garlic here, for instance, which is the first entry in our price updates dictionary, then we're going to update column 2, so the price for it, and we're going to update it to the new value. So instead of $1.19, it's going to be $3.07. And at the end of that, we are going to save our workbook, and we're going to save it under a different name. So updated produce sales is going to be the new Excel file that's going to be generated. So let's run our program. And of course we don't have any output, but let's have a look at the new Excel sheet that has been generated. So this is a new Excel sheet that has been generated, updated produce sales. And if we take a look at garlic, for instance, we can now see that the price has indeed been updated to the new price value. So that's one way we can use to easily update an existing spreadsheet and then, for example, save that as a new spreadsheet. We can not only update values in cells, but we can, for instance, also set the font styles of various cells. So in the project we just worked on, we could have said, for instance, that we want to highlight the various cells that have been updated. For example, the column for garlic and also the price. We could have made that bold, for instance. And that's possible through the styles module, which is also part of the OpenPyXL module. So to work with that, we need to go ahead and we say we want to import font from OpenPyXL.styles. And then, for instance, we can generate a new workbook, which we're going to call WB. Let's reference the default sheet here in the variable sheet. And then we can go ahead and we can create a font. So here we are creating a variable italic 24 font, and we are creating a new font object here with two attributes. The size, which we set to 24 pixels, and then we also set that to italic. Now we still need to apply that font to our sheet. So here we are referencing our sheet from before, and we want to set that font for the cell A1. And if we now populate our cell with some values, so for instance with the string hello world, those styles would be applied. And then of course finally we can go ahead and we can save our workbook. So we are going to save it as an Excel file under styles. And if we now open that file that has been created, then we can see that indeed we have that string hello world in our cell A1, and it has been formatted accordingly. So it has a font size of 24 pixels and it's also displayed in italic. Now, as we just saw, we can set font attributes, which we can pass to the font function. And here's an overview of the different arguments available to us. We already took a look at the size attribute, which is the point size, and also at the italic keyword argument here. We can, aside from that, also decide whether some text should be bold, and we can also specify the font name that should be applied. For example, Times New Roman or Calibri. In Excel, it's of course also possible to work with formulas, and we can do the same here in code. So as an example, we can sum the values of multiple cells to give a total value. And we can do that using Python. So for that, of course, again, we would import our module and create a new workbook. We would select the active sheet that we're working on. And here we are setting the value of the cell A1 to 200 and the value for cell A2 to 300. And then we can go ahead and say that the value for A3 should be the sum of A1 and A2. Let's save our file as write formula. And now if you take a look at that Excel file, we can see indeed that we have a value of 200, a value of 300, and the sum total here of 500, which of course is the sum of the two values above. We can also adjust the row height and the row width using Python. As an example, we can go ahead and we can create a new workbook here, and then we are going to set the cell value for A1 and B2 to various different texts. And now in order to set the row height and the row width, we can go ahead and we can select the sheet, and then we can set the row dimensions for the first row. In this case, we're going to set the height to 70 points, and then we're also setting the width of column B to 20 points. Let's save this Excel sheet again, and if we open it up, we can have a look and we can see that indeed the first row here, its height has been updated to 70 points, and the width for column B has been updated as well to a total of 20 characters that can be displayed in this column. We can also use Python to freeze certain panes, so that means even if we scroll within our spreadsheet, those frozen panes will basically stay in place and will always be displayed. And here's an overview of some examples. So for example, we can freeze individual rows, for example here row 1. We can also freeze columns, and we can also go ahead and, for example, freeze multiple columns by calling freeze panes on our active sheet and then specifying the cell which should no longer be frozen. So in this case here C1, which would mean that columns A and B, the ones before, would be frozen. Let's have a look at an example, and we're gonna load a workbook we've seen before, the produce sales Excel spreadsheet. And what we want to do is we want to freeze the topmost column, which included the different titles, so we can always see that even when we scroll through our Excel spreadsheet. For that, we're going to select the active sheet, and then we are calling freeze panes on that active sheet, and we are setting it to A2. That means the rows above A2, so the first row, will be frozen. And then of course we need to save that under a name, so in this case we are just going to call that Excel sheet freeze example. And if we open up that spreadsheet, we can see the first row here is frozen, meaning if we scroll down, the first row will always stay in place. And finally, we can also use the OpenPy Excel module to create charts, for example, line charts, pie charts, or bar charts. And to make a chart, we always need to follow a certain series of steps. So we are first going to create a reference object from a certain rectangular selection of cells. So for instance, we may want to select an area like this. Then we need to create a series object by passing in the reference object. We then create a chart object. Then we need to append the series object to the chart object. And then finally we need to add the chart object to the worksheet object in order to display our chart. So let's have a look at a practical example. We of course need to import our module, and we need to specify a new workbook. We are going to select our active sheet, and then we are going to create some data in column A. For that we are going to take a look at the range from 1 through 11, and then we are just going to add some text to the different cells. So here A plus the number, so A1, A2, etc. And then we are following the steps we just saw before. If we think back, we need to first create our reference object. So here we're passing the sheet, the minimum number of columns, the minimum number of rows, and then the maximum number of columns and the maximum number of rows to the reference function here. Next, we're going to create a series object by passing in the reference object. And here we are also providing a title, which we call first series. After that, we need to create a chart object. So in our case here, we are going to work with a bar chart, and we are going to save that in chart object. We are also going to provide a title to our chart object. We're just going to call it my chart. And then we need to append the series object to the chart object by calling append on chart object and passing in the series object as an argument. And finally, we are adding the chart object to the worksheet object, and we are also specifying which cell should be the top left corner of the chart. So here we are calling add chart on our sheet, we're passing in the chart object, and we are specifying the cell C5 as the top leftmost cell of our chart. Now let's save that as sample chart, and let's have a look at that Excel spreadsheet. So we can see we have our numbers here 1 through 10 in the A1 to A10 column, and then in C5 in the cell here, this is the top left corner of our chart that we are generating, and here we have that bar chart that we specified. Let's have a look at the practice questions. What does a load workbook function return? So it's going to return a workbook object. What does a sheet name workbook attribute contain? So the sheet names attribute contains a worksheet object. How would you retrieve the worksheet object for a sheet named sheet1? So let's say we opened a workbook and that contains different sheets, including sheet1. Then we would use this syntax here. We would reference our workbook, and then in bracket notation we reference sheet1, and we can for instance save that in a variable. How would you retrieve the worksheet object for the workbook's active sheet? So to do that we would reference the active attribute on the worksheet. How would you retrieve the value in cell C5? So for that we can reference C5 using sheet and then brackets C5, and we want the value, so we reference the value attribute. How would you set the value in the cell C5 to the string hello? To do that we need to reference our sheet specifically with this cell C5, and we're gonna set that to the string hello. How would you retrieve the cell's row and column as integers? So for that we're going to use the syntax cell.row and cell.column to reference the row and the column. What do the sheet.maxColumn and sheet.maxRowSheet attributes hold, and what is the data type of these attributes? So they hold the highest column and the highest row values, and they're stored as integer values. So there's the syntax we can use to turn the columns from integer values to letters, which are used in Excel, but by default both of those will be integer values. If you need to get the integer index for column M, what function would you need to call? So for that we of course are going to use our OpenPyExcel module. We are referencing cell and then column index from string, and we're passing in the letter M, and that's gonna give us back the integer value. If you need to get the string name for column 14, what function would you need to call? So for that we are going to use getColumnLetter, and we pass in the integer value, so 14, and that's gonna give us back the corresponding letter value. How can you retrieve a tuple of all the cell objects from A1 to F1? So for that we would simply reference our sheet and we pass in the beginning cell, so A1, a colon, and then the ending cell, so F1 in this case, and that's gonna give us back the result we're looking for. How would you save the workbook to the file name example.xlsx? So for that we are going to call save on our workbook, and we pass in the name under which we want to save that Excel file. How do you set a formula in a cell? So we would set a formula in the same way as any other value. So that means we would set the cell's value attribute to a string of the formula text. And we need to keep in mind that all the formulas begin with an equal sign. If you want to retrieve the results of a cell's formula instead of the cell's formula itself, what must you do first? So for that we would call load workbook, and then we would provide data only as a keyboard argument and set that to true. How would you set the height of row 5 to 100? So for that we are going to call row dimensions with a value of 5 on sheet, and then we reference the height attribute and set that to 100. How would you hide column C? So for this we are going to reference column dimensions C on sheet, we're referencing hidden, and we set that equal to true. What is a freeze pane? So freeze panes are rows and columns that are always displayed on the screen. So they're basically stuck to the top or to the side depending on whether it's a row or a column. And they're really useful for headers when we basically want to scroll through a very long Excel spreadsheet and we still want to see, for instance, the headers being displayed. What 5 functions and methods do you have to call to create a bar chart? So to start out we need to create a reference object, which we are doing by calling chart.reference on the OpenPyExcel module. Then we need to create a series object by passing in the reference object. For that we are going to use .series. We then need to create our chart object, so in our case here bar chart, using the bar chart function, and then we need to append the series object to the chart object. So here we are calling append on the chart object and we're passing in the series object. And then of course we need to add the chart object to the worksheet object using add chart, and optionally we can specify which cell should be the top left corner of the chart that we are generating. In this video we covered how we can work with Excel files using Python. In the next video we're going to take a look at how we can work with Google Sheets as an alternative to Excel spreadsheets. Feel free to subscribe to the channel to stay up to date whenever a new video is released, and see you guys in the next video.